Ever since childhood, I have been fascinated by the strange phenomena in the world around us. When children of my age went to the beach to swim and sunbathe, build sandcastles, or to roll around in the hot sand, I would pick up fine sand and watch it flow through my hands. And it is thanks to this fascination with sand that I found the thesis of my topic. Indeed, my thesis focuses on the dynamics of granular media. And what exactly is granular media, you ask yourself? Well, it's simply an environment composed of a large number of distinct solid particles, more commonly called grains, and found in sand dunes and avalanches. Even a teaspoon of sugar contains hundreds of thousands of highly irregularly shaped particles that undergo complex interactions with their neighbors. Sand is the most representative material of granular media, the one that intuitively comes to mind when you try to imagine grains in contact. My thesis, thanks to a computing technique called high-performance computing, a sort of supercomputer, I will be able to develop methods to evaluate the performance and carry out the validation of mechanical, mathematical, and numerical models. So, what is so interesting about simulating sand, you ask yourself? Well, you can use it to build sand castles on the beach. But what is so interesting about it? What can be interested about simulating sand? My research involves carrying out a numerical study which will determine the dynamic behavior of these grains in this environment. So in order to simulate their flow, such on an inclined plane on a sand dunes or on a small scale on few particles. Outside academic interests, granular media have high economic importance in fields such as energy generations, construction, food production, and in the general process industries. So, from that little boy I was then, to the scientist I've become today, I am trying to see the world in a grain of sand. Thank you, everyone.